Yeah, ma'am, please start. Yeah, thanks.
Okay. So let's start with a quick recap on yesterday's session. So yesterday we have covered Kubernetes storage and role-based access control. So we'll continue with the role-based access control where we left off yesterday. And then we can start with the today's session of Helm charts. Yep. So quick question. Why do we need storage in Kubernetes?
Because pods are ephemeral.
Right. So the data is lost when the pod dies. So we have seen two different types of provisioning. What are those?
Static provisioning and dynamic provisioning.
So in static provisioning, we provide the details of persistent volume claim, and in the deployment, we'll call the persistent volume claim. But when it comes to dynamic provisioning, we use a storage class to create the persistent volume, and then still use a persistent volume claim that's mapped into your deployment file. Okay. So that's the main advantage. You don't need to specify the persistent volume configuration. If, for example, if a developer, they do not specify any storage class name in their persistent volume claim, what will happen?
It will point to default storage class.
Yes. So, but in the default storage class, they have requested for read write many. So this is an access mode. So we have three different types of access modes. One is read write once, read write many, and read only many. So these are three different types of access modes. So my storage class is supporting only read write once, but I have created a persistent volume claim with storage access mode read write many. What will happen in this case? Will it create a persistent volume?
Yeah, not sure. I think so. It will create a new storage class with a new claim.
It should fail because not all the storage class support this access modes. So if your storage class does not support read write many, and if you are asking for a claim with read write many option where you don't have that type of storage class available, then it will fail, stating that we don't have persistent volume matching that resource. So you will get such errors. So you'll have to be very careful while creating a persistent volume claim. So in such case, how to fix the error? You'll have to create another storage class specifically to address that issue, and then use that storage class name in the persistent volume claim. So in such scenario, you would definitely have to pass the storage class name in the persistent volume claim file. Okay. Yep. Any questions from yesterday's class? Okay. Then we'll continue the RBAC session where we left off. So what are the four different types of objects when it comes to RBAC?
Role binding, cluster role, and cluster role binding, I think.
Yes, exactly.
Yeah.
So when do we use role and role binding?
Namespace level.
Exactly. And cluster role and cluster role binding?
Entire cluster level.
So what are the different users that you can pass in when you create a role binding? So there are three different options to bind the role to specific user. What are those?
System user.
Okay.
IAM users.
Okay. So let's dig more into the RBAC user types. So we have seen this file yesterday. So this is going to be your API group, and what are the resources that you want to watch, and then these are the verbs. What are the action that you are going to perform onto that resource? So this is a simple role, and in the role binding, what you will give? You will give subjects to which user you are assigning it. So there are three types of resources, which is user, group, third one is service account. Okay. So user is only single set of user you are assigning permission. Group means an AD group where list of users are added for any particular team, and then you will assign this specific role to that group. So whoever part of that group, they will get access. So they will get watch list access to the secrets. For example, if this is my role, they will get access to these resources. Okay. So the third type of subject is storage service account. So why do we need service account? So we don't, sometimes you always don't need to use your account to perform operations. So you will deploy an application. That application needs access to rest of the resources, rest of the Kubernetes API. So in that case, what you have to do, you have to create a service account and then assign that service account the role. So basically the role will be similar to this even for the service account. But in the role binding, what you will have, you will just, instead of user, you will give service account and then pass the service account name. Okay. So that's the only difference. Otherwise, this configuration will remain same for user, group, and service account. So when do we use service account? It's not the human account, it's the system account. When an application want to communicate with other resources by connecting to the Kubernetes API. So in such case, you will have to use service account. So in the production, what are all the use cases where you will use service account is, for example, you have Cilium. So we have installed Cilium, right? So Cilium needs permission across all namespaces. Okay, so to perform any operations, because each and every node has to spin up a pod, and then it also need access to all the pods, and then we are having the network policies, and also it needs a wider role. So in that case, you will create a service account, and then that service account will have cluster role and cluster role binding to have access across entire cluster. So that's one use case. And you are monitoring also. So for example, so we have an application like Prometheus and Grafana to collect the matrices. So how a matrix will be collected? Is it collecting across namespace? No, right? It has to collect across your cluster. So it has to collect the metrics from each and every node. So it needs a wider access. So in such case, you still will create a service account and then create a role and role binding. So for which resources it has to have permission, and then you will assign that to that application. So Prometheus and Grafana, Cilium, every Helm releases that we do, it will have role and role bindings. Okay. Now, Priyanshu, you asked this question yesterday. Did it?
Yeah.
Yes, Swarna. Go ahead.
Yeah, so if we don't specify any RBAC in the cluster, so will applications get by default permissions onto any namespace?
So if you don't provide any RBACs, so but if your application needs access to specific Kubernetes API, then it will fail.
Okay.
Okay.
Yeah.
But when we create the Selenium, we haven't specified the RBAC that time. So, but they able to show all of the services. So they have a by default access.
Yes. So basically, when you don't, so all the tools, whenever you install it via Cilium CLI or using Helm chart, so by default, they will add cluster role to your cluster. Okay. So you don't need to specify, that's by default.
Okay.
So it will definitely have a service account, role and role binding mapped to that application. So though because this is must for that application to work. So you don't have to specify this. So that's by default, and by design, they will add the cluster role and cluster role binding. In some case, if you want to change the service account name, then you will have to specify during the installation. Otherwise, it takes the default one and then it creates a cluster role and a cluster role binding. So just let's see if I have a Cilium in my cluster. And then you will see the service account. Okay, so I have installed Istio, but I have not created any service account. I have not created any role and role binding myself. Okay, I just used the default configuration. So if I get to check the service account, SA is the alias for service account. So PV is the alias for persistence volume, PVC for persistence volume claim, and SC for storage class. Okay, so you will see these roles. So these service accounts are created. So if you describe this service account, you will see what role and what role binding you have. HTTP cluster role binding. So for Istio gateway, it has a role binding. So this is the cluster role binding. And then if you see the subject, it's the service account name called IstioD. So I should see the service account in Istio system namespace. Okay, so this is the service account that's created within that namespace, and then what role it has assigned. So you will see the role. This is the role. In the role binding, you will see what role and what service account is assigned. So if I have to check what permission is it had, cluster role. So see here. So it has apps is for the deployment, right? Apps is a deployment API group. And then in the deployment, it has all these permission: get, list, watch, update, patch, create, and delete. And auto scaling, it has permission for horizontal pod autoscaler, pod disruption budgets, and then service account. So it also has permission to create a service account. So this is your Istio system has all these permissions. Like basically your Istio D has created a service account, and then it mapped a cluster role and cluster role binding by itself. I have not configured any of this. So I've just installed the Istio using some Helm chart or whatever possible ways, Helm chart or CLI or just a plain manifest. It creates all these resources by default. So you don't have to configure which service account, which cluster role binding. It is taken care by default. Okay, did that answer?
Yes, yes.
So
Have
now, yes,
we studied Istio in our previous classes, or you will teach me?
we have not started the Istio. I'm just showing you for some example. Okay.
Okay.
So we will cover Istio maybe in the next session. So we
Okay.
are covering Ingress and Istio. So just to don't get into the Istio, just understand what is the concept of role binding and then service account. So that's what we are looking at it.
Okay.
So we are going to cover. So
Okay.
I thought I would show something for Cilium so that you will understand better, but I don't have Cilium installed on my current cluster. But you can check it in your Cilium configuration. What is the role binding, and then service account. So just to add more details on service account, I just pulled up this example and showed you. Okay, good then. I think we can complete the lab along with the Helm chart lab. So it's not difficult. So now you understood the concept of role binding, and cluster role binding, right? So we can jump into the Helm chart and then we'll continue the lab. We'll club it with other. Okay. So anybody know already what is Helm chart? Just unmute yourself and quickly answer.
Yeah.
Yeah. Go ahead. What is that?
Actually, suppose if we want to create a ingress for the suppose we want to create a deployment. And we have a three environment like development and the stage and the production. Okay, so we have to create the multiple files for that. But with the help of Helm chart, we can simply pass the values in the values.yaml. Like in the dev, we want the 5 replicas. In the production, we want the 10 replicas, and in the stage, we want 5 replicas. So we can put the values on the one file, and it will create the a whole infra, right?
Yes, exactly. So just to name it, Helm chart is a package manager for Kubernetes. So it's a way of installing. For example, in Mac, we have VXC, sorry, in Windows, we have EXE and MSI, right? So similarly, for Kubernetes, we have Helm chart is one of the way to install any application. Okay, so basically it is going to install the same manifest file that we have seen so far, deployment, services, everything. We were installing it manually. So instead of manually deploying it, we package it and then install as Helm chart. So, so for this, you need to have a Helm CLI installed onto your machine. Helm, it is a tool that install application to your Kubernetes. Okay, and then what's the main advantage of using it is you can manage versions of it. For example, if you want to do a next release of your application, then it's easy for us to do the release. So just change the release and then update some values and then do the release. So using the just simple command like Helm install, Helm upgrade command, it's just going to do everything for you in just one command instead of deploying using kubectl apply -f and applying all the manifest. So you don't need to do that anymore, and then it can be simplified using Helm charts. So we'll see the structure of Helm chart. So let me. Okay. So can someone tell me what are all the files? So initially you said like 2 to 3 class before, someone said we need deployment and services to deploy any application. So now we have covered so many classes, right? Like after that. So what are the files that are required? Any case, and then just list down those files for onboarding a new application.
Namespace, deployment, service, and then scale HPA scaling or whatever the scaling, and ingress. I mean, like policies, network policies.
Okay.
And yesterday's storage class, and then roles and role binding.
Good. Role bindings, your persistent volume claims, and then config maps, secrets if your application is connecting to some database. Okay. And then if it's, we have not covered ingress, but if your application has to be exposed outside, we'll have an ingress resource. So very basic things, right? So for example, if it requires cluster access, cluster role and cluster role binding. So it will keep on increase, like it is going to increase forever. So it's not going to stop. As in when we add a new tool, then each and every file will be added. So for example, if you are going to add an Argo CD, then you will have to add an Argo CD application. And then if it's an Istio, you will have to add Istio related files like virtual services and all. So Istio related configs need to be added. And if you have to scrap the metrics, again, additional files will be added. So without Helm, how your deployment file will look like, the manifest file will look like. Let me show you. So without Helm chart, it's going to be a big, huge list of files like namespace, config map, secret, service account, cluster role binding.
Are you showing something? Because we can see only the chat.
Is it? Okay.
I can see only the slides.
Okay. No worries. Let me reshare you. Is it visible?
Yes, it is.
Okay. And are you also seeing this page? Right.
Yeah.
Okay. So these are the files that are minimally required for creating an application, for onboarding any application to Kubernetes, right? So these with these files, how your deployment how your Kubernetes manifest will look like, it will be a huge list of files. So sometimes it can cross up to hundreds or thousands of lines of code. So in order to investigate, in order to do a release, it will be very difficult. So you cannot reuse it for other environments. You'll have to create another set of similar files, and then you'll have to modify according to your environment, and then you'll have to modify the images, versions, and then for non-prod you don't need a request and limits too much. So for production you might need a very huge resource. So such type of reconfiguration is not possible without Helm chart. Okay, so let's see what is the Helm chart and how does it look like. So basically your Helm chart is going to have these 4 files or folders. So chart.yaml is one of the file, and then we are going to see what is chart.yaml has, and what is values.yaml, charts, and what are the templates. Okay, so just understand like this. So all these files, so far we were seeing this namespace, config map, secrets, deployment services, and HPS. All these files are your required configuration required for your Kubernetes manifest, right? So all these will go and sit in your templates, which is this one. So under templates, you will have all the configuration that we have deployed manually so far. So it is going to sit under templates. And then chart.yaml. So chart.yaml is nothing but it's just the metadata of your chart. Okay, it's going to give your details like what is the basic information about your chart. For example, it has a name, right? You can name like HR applications. So just basic information about what version of your application, and then what is your name, and then you can add Helm chart description as well. So why it is needed, and then it has. So what is the difference between these two, API version and version? So it's actual application version, and this is your Helm chart version. Okay. So this is how your chart.yaml will be present. Okay. So what is the use of this chart.yaml? It identifies the Helm chart, and then it is mainly for version management. Since we have marked the version, so with this version, it's going to release. So next version means you will have to update it to 1.1 or 1.2, and then based on that, you can do the Helm upgrade. So that's for the version management. So basically, you can identify what is the chart.yaml has. It has the identity of your chart plus versioning of your Helm chart. So that's just the name and then versioning. So just understand that. So this is not going to be a very difficult thing to understand. Just we'll go and look in further for rest of the files. So first we have covered chart.yaml, and then we understood what is going to be there in the template file. So now we will understand what is a value.yaml. Okay, so the template will have all the Kubernetes manifest required for your application. So we have seen that already. So what does a value.yaml contains? So basically we are providing all the values here, right? Like number of replicas, what is your service account name, what is your CPU request and limit, and what's the port. So all these information are hard-coded in your deployment. So
your screenshot slides, chart.yaml.
Okay.
Lavanya, slide we are still a start again.
Let me share again.
Are you sharing the entire screen or just a window?
I'm sharing the entire screen, not the window. Screen. Okay, let me switch between the windows and see. So now my slide is visible, right?
Yes.
Okay, and then my VS Code is also visible, right?
Mm-hmm.
Okay, fine.
Yes.
So these These values we are hard coding when it comes to deployment. So the replicas are hard coded, and these resource request limits and the image name, everything is hard coded here, right? So if we move all these files like these service accounts, deployments, cluster roles, service accounts, everything, if you move it inside the template folder, then it's going to be hard coded files, right? So still your deployment will have one replicas, but you don't want that, right? For reusability, you want this as a variable, right? So that you can just pass in value for this replica, and then you can just configure it for each and every different environment. You don't have to reconfigure much things. So how it is going to be done? My slide is visible, right?
Yes.
So how it is going to be done? So in the replica count, you will configure a value. So if value.yaml is just the configuration required for your application. So whatever values you feel like it's going to change, you can configure it under values.yaml and pass it to your templates. Okay, for example, replica count, image, tag, services, and then request limits, probes, everything you can configure. Okay, so how do you access this? For example, I have configured replica count as 2. So in the template deployment file, it's going to be read from the values, under values, replica count. So it's going to pass this value to your deployment. So now it's going to be all the variables. So deployment file will have all the variables assigned to it. So just to pass the value, whatever you need. If you're not passing any value, it's going to take the default value. For example, if I have set a default value of replica count to 2, if you don't specify anything, it's going to take the default count. If you can just override it by specifying this replica count to 4 in case of production, and if in case for test environment or non-prod environment, you can just mention 1 and then just test your application accordingly. Okay. So that's the use of this values.yaml. So basically passing the configuration to your application. So that's the use of values.yaml. So this is where you will do a lot of work here. Like you'll have to understand what is the structure of values.yaml, what are the values you need to pass in. So then if you understood this, you can create your own Helm chart by any means, and then you can deploy the Helm chart however ways you want. Okay. So we are going to see an example how to create a Helm chart from scratch and how to reuse the Helm chart. Okay. So basically the flow will be developer. So basically we are not going to create it. Actually, this is going to be your developer's work. But most of the developers, they won't do the Helm chart creation by themselves. So what you have to do, you will create a structure for them and then pass this Helm chart to them so they can use it. So they are not going to build it from scratch. So you create the templates and then pass it on to them. So if they need any custom requirements, like they want to increase the resource quotas, so you add a resource quota file and then provide a resource quota configuration for them. So such configuration, you can update it. So just adding a new file to the templates and then passing that value to values.yaml. Okay. So like that, you can customize the existing Helm chart as well. Okay. So how you are going to create? You will use a Helm CLI. So using the Helm CLI, you can create a new Helm chart. You can install the existing Helm chart, and then you can do an upgrade to next version and then roll back to the previous version. So, and then you can create a template. So if you want to list all the templates, you have a template option available. And if you want to uninstall, you have uninstall command. So these are basic commands required by your Helm CLI when you work on the Helm chart-based deployments. So these are the commands basically we use even in the production. There are few more commands like get values and all. So that's not widely used, but you can get to know if you understand the Helm concept. That's it. So the benefits we already see, we have already discussed, like it is going to simplify our deployment structure, and then we can reuse it by passing the information in values.yaml and then have a different values across your environments. So that's the reusability. And then it's easy to configure values.yaml, and accessing is also so easy just by reconfiguring or overriding the values. And then it's for version control. So you can roll back to the previous version of your application and then do an upgrade or rollback. So both are possible. Okay. And then, yeah, these are few list of commands. We are going to see that in detail in our lab today. And this is again going to be your variable. So this is going to be in values.yaml. And then this is going to be inside your template files, template deployment file. I will show that to you in some time. So another important thing in Helm chart is functions. So you can use few basic functions within your Helm chart. Like if you want to convert it into uppercase, or if you want to add it to YAML, or then you want to add a quote. So those type of simple functions is possible. And then if you want to pass in default values, your replica count has to be 2 means you can just mention default as 2. If nothing is specified, it will take. So simple functions are available. There are much more functions available, but you just understand what's the use of function, then you can explore further and then make use of it. So in real world, do you think we will create a Helm chart from scratch for all the application deployments like Cilium and Ingress? Yeah, for all the deployments, do you think that we are going to create a Helm chart? So then it is going to be too much work for us, right? So how it is going to be done? So we have all the charts, publicly available charts here in the artifact hub. Okay, so let me show you that. My screen is still visible, right?
Yes.
Okay, so this is called as Artifactory Hub for Helm charts. So you can just go ahead and search whatever Helm chart you want to explore, then click on that Helm chart. So you will see all the procedure, like how to add this Helm chart, how to install this Helm chart, and then you can also see all the files that we were discussing. So this is going to be your templates. Under templates, it's creating the cluster role, and then cluster role bindings. So all the template files, it's going to list. So I was telling that we have to use these values, like values. So this is going to be passed from values.yaml. So in values.yaml, if you specify any annotation, it will be picked up and then added here. Okay, inside the annotation with the indentation of 4 means, and with 4 indent, it will move and then it will add that values under annotation. So common labels, in the values.yaml, it will check for common labels and then it will add under labels. So you can just, so this is how it is going to pass the values.yaml inside your templates. Okay, so this is how it is going to be referred. So I have told you this cluster role binding. We are not specifying anything when you installed the Cilium Helm, Cilium using CLI. So we have done only using CLI so far, right? So we have not passed anything. So still it needs a cluster role and cluster role binding. So those are default configuration. It's required, and then it will go and install it by itself without us specifying any configuration additionally. But if you want to change it, you can change it by passing it in the values.yaml. If not, it's going to be a default value. Okay. And Cilium uses a daemon set, config map, role binding, services, service account. So everything is going to be picked up from your values.yaml. If you don't specify anything, it is going to take the default value. Okay. Any query up to here?
Ma'am, is it similar with the customize?
Yes. Customize is another way of installing applications, but this is widely used. We will see the customize as well. It is another way of rolling out the application.
We will cover this in our classes, right?
Yes.
Okay, thank you.
So basically, customize, Kubernetes also has a customize, and then other tools will also provide some customizations like Flux and Argo. They will have their own customize, and you can make use of it, and then sync the files directly. Okay. So basically, what they will do in dev folder, they will put few files. Okay, and in prod also they will put few files. In base they will have the master configuration. So whatever you want to override, you will put that in dev and prod. Otherwise, base configuration will be used. So that's the use of customize. Like you can customize your environment If you don't have a customization, base folder files will be installed. Okay, that's the one-liner. But let's see how we can cover it. Maybe in the Argo series session, we can cover customize, which is relevant there.
Now, a quick question. Any alternatives to Helm? Because I see Helm is widely used across whichever
Basically,
you mentioned.
Helm is widely used for all the application, because in the artifact repository, you will see each and every tool will have their own Helm chart. So how you are releasing the Helm chart, that's for that you will have alternatives. Like you can use Argo CD. Argo CD supports Helm chart rollout, and then Flux CD also has a support to roll out Helm chart. So you don't need to mention all the Helm configuration, just to mention from where this chart has to be used in this artifactory. So from here, it will just pull it using just a single file. So Argo CD is the same. Like for Argo CD, you just need an Argo CD application file. In that application, you just call the Helm chart. Okay. So if you call that Helm chart, it will just install it with the default values. If you don't give any overrides, if you give any overrides, it is going to customize it for you. Okay, from the values from the templates that you have seen here. Okay, so Argo CD is one such way to roll out the Helm chart, and another alternate is customize. So using customize also, you don't need to have a Helm chart at all for customize. All that you need is YAML files defined. For dev, specific set of YAML files, and for prod also specific set of YAML files. So you can either specify two different set of YAML files, or you can specify a single set of files like base. So that base file will be deployed onto your dev and prod. But if you want overrides, then you can configure that single file alone in your dev. So if it is for dev, it will pick up that dev configuration. If it's for prod, it is going to pick the prod configuration. Okay. So no templating is needed for customize, just making use of as-is YAML. But in Helm chart, you will have to templatize and then override with Helm values.yaml. Okay. So just to patch and use YAMLs. So that's for the customize, but create it as a package for Helm chart. So both are widely used, but for rolling out any tools, Helm is the standard way of rolling out. Did that answer finish? Okay. So Terraform also, using Terraform also, we will deploy Helm chart. So that is a way possible to roll out any Helm chart using Terraform provider as well. But underlying concept is going to be the Helm chart. The way we roll out is going to differ. Like it either can be from Argo CD, Flux CD, Terraform. Yeah, different ways to roll the same. Yeah, customize is an alternative.
So this the way we roll out, most of the places they use Terraform, like it's commonly used, right? For the
So basically, during the cluster creation, right, you need a Cilium to be installed. So that time you can configure using Terraform. But after your cluster is ready, you have Argo CD deployed, right? So from Argo CD, you can just make use of GitOps way of deploying. So you don't need to use Terraform every now and then. If you use Terraform, what is the drawback of Terraform? You'll have to do a Terraform plan every time, and then you'll have to roll out, right? So that's the drawback of using Terraform to roll out any Helm charts. So, but for cluster bootstrapping, you will use Helm chart. So for cluster creation itself, I'm creating a Kubernetes cluster. I can create it using Helm chart. And then after the cluster is created, you need some way of deploying applications, right? You decide on which tool you are going to use. For example, I am going to use Argo CD as my GitOps tool. So then you will roll out Argo CD using Terraform. So once Argo CD is spinned up, then Argo CD is going to be your main tool to roll out. So in the Argo CD, you will call the Helm chart, and then you will deploy your application using Argo CD. So not using Terraform. So, but both the ways are available. Okay.
Sorry, this is the first class actually. So I just have one doubt. I don't know, it's basic doubt. So when we use Docker, this one for the setup, for like the interface itself. So there are 2-3 options that we can use. So whatever you're saying right now is can be used. We can use Docker also instead for deploying.
Basically, Helm is the way of rolling out in Kubernetes. It's not designed for Docker. Okay, that's the package
Okay.
manager for Kubernetes.
Okay.
Okay.
Got it. Okay. Thank you.
But in the Docker, you can just run the image and then start the container. So Docker run, image name, port name, configure it, start it, and use the application within the Docker container, right? But when it comes to Kubernetes, you need deployment services to start an application. So there are various advantages of using Kubernetes. Just to go through the previous classes, you will get to know better. Yeah.
Okay. Okay. Thank you.
Yeah. Thank you, Tanisha, for the question. So let's move on. If you don't have any question. Okay. So that is how it will be. So Helm. So in the artifact repository, we can install Nginx, Cilium, Keda, Kyverno, Prometheus. So all these tools I mentioned because we are going to cover in the upcoming sessions. So these are the two major tools that we will cover. Okay. I think with that we can start the lab. Any volunteer for today?
Yeah, sure. May I?
Priyanshu.
Okay. Are you able to see my screen?
Yes, it's loading. Yes. Can you do the clone again? Because I have pushed some changes this morning.
Yeah, sure. 1 second. Week 4, right?
Week 4 readme. So we will continue with the storage account and then complete that and then go for the Helm chart.
This one. Yeah.
Yeah, go up. So yes, role binding. Yeah.
Okay. So do I need to run these commands?
Yes.
RBAC. Okay.
Yes.
What do I need to check? I just run the kubectl get role binding.
So the role binding. So we'll go through again what's there. Yeah, so this one, right? So
Yeah.
here what we are doing, we are creating a namespace, creating a role to list, get, watch pods, and then doing a role binding to which user? Come down. Yeah, dev user, right? Okay. So
Yeah.
now do the kubectl auth command. Just copy the command in line number 54 up to dev. 52, sorry, 52. Yeah. So this auth command is to check whether the dev user has permission to list bot. Okay, now instead of list, just edit it to delete. No, right?
Okay.
So what we have done, we have only done assigned permission for get list watch action. Right? We did not assign permission for delete. So now you do one thing, you can go ahead and update the line number 22 in the role binding YAML. line number 22. So add, delete. So now you should be having access to delete.
Yeah. Okay.
Okay. So it's just the way of updating the permissions. If you need excess permission, you can add. So this is just for pods. For deployment, you need another set of configuration like deployments. And then for storage class, a different configuration, because storage class and deployments falls under different API group. It's not the core API group. So basically just go through the set of commands. Maybe I'll take a screen share for a moment. Okay. I think you can still access my screen share, right? Yeah, I think you can still check my screen sharing session. So what I wanted to show. Yeah. So I want to show, yeah. So just see here inside the cluster role for
We cannot see your
then
screen.
can you Priyanshu, can you share?
Now it's fine. Yeah.
Visible, right?
Yes,
My
yes,
screen is visible,
yeah.
right?
Yes.
Okay. So basically what we will do, so for example, if you create a cluster role to list the pods and services, so it's going to be under core API group. But for network related stuffs and for endpoint slices, it will be under a different API group. Then you will have to add additional configuration, and for that resource, you'll have to add permission. So in the real-time scenario, how it will look like? It will look like a big set of files. So I think you have seen for Cilium, right? So we did not mention like a single rule. So we have passed the rule as an array. So for deployment, it falls under apps API group. And for auto scaling, it falls under different API group. Yeah, PDB, it falls under different API groups. Similarly, you'll have to configure for each and every API group. You'll have to configure accordingly, then it will not work. So you can, otherwise, if you don't mention anything, for storage class. So you cannot add storage class under core group. So services, pods, storage class, it's not going to work because it's not under core API group. So storage class is under storage.kh.io group. So that group, inside that group, you'll have to pass service. So here it will be storage.kh.io. And then here it will be storage class, persistence, volume, everything. And then get list, watch, delete. So that then only you will have access for storage class. Okay, I have given one assignment. Just go ahead and check, and then do it for user and do it for service account. Just go ahead and try it when you have time. It's not going to take more than 15 minutes because you understood the concept of role and role binding already. So and now you also know where to look at the documents. So just go into the kubernetes.io and then just search for role and role binding. It will give you this page, and then explore it. Just to go through this file and then create your own version of it. Okay. So that's how you are going to make use of it. Yeah. And for service account also, they will have a sample how we are going to use service account. So yeah, like this. Okay. Yeah, go ahead, Priyanshu, for the rest of the labs.
Sure. I can run the commands from 57 line.
Yes, I'm not seeing your screen. Let me check. Yes, go ahead and run the rest of the commands.
Okay. I think there is some issue in this command. Kubectl can I more than this?
Okay. If we run Nginx pod,
I think you have to remove Nginx.
Okay.
Just one quick question, Lavanya. I can see that there are 5 weeks. Today is my first day. So does it mean that after week 5 it restarts again or something? The course.
this is going to be a 10-week program. So we are
Okay.
under week 4. Okay. So I don't had a labs prior. So I just create a week before. So yeah. So we have covered 4 weeks. Just to go through the 4-week contents and then do the lab and also assignments, so that you will follow everything before coming to the next session, which is going to be the next Friday probably.
Okay.
And also please try to attend the live classes rather than going through a recording. So yeah. So that you can raise your questions there.
Okay.
So what we were doing, we are creating the cluster role and the cluster role binding now. Okay. So, and then validating which user has permission. So this auth command is going to mimic like a cluster user or any service account. So whatever way you can just mimic it and then check whether that resource is having access, whether that user or service account has access. So it's just to mimic whether they have access. So for example, if a user called a cluster user logs into the cluster and checks, they cannot do the same. So this is just to validate. Okay.
Okay.
It's like IAM or something like authorization management.
Yes, just for specifically for clouds, right? Azure AD, Entra ID, and yeah. Okay. IAM, but this is Kubernetes role-based access control. So with respect to Kubernetes, if it comes to role-based access control for Kubernetes, you'll have to use role binding, cluster role, and cluster role binding. So these are the 4 major resources that we will use for role-based access control in Kubernetes. So it's Kubernetes access mechanism. Okay.
Okay.
If you don't mention any permissions, then it will use the default account, and then so each and every namespace will have default storage account. That default storage account will have specific set of permissions. So then with that it will work. But you will also have to start with a minimal permission. So that should be your intent. So you'll always least privilege is the concept that Kubernetes has to work. So that is the reason why you'll have to always understand what these roles and role binding does, and then you'll have to start with the minimal permissions. So for example, if some audit comes in, and then what they will first look at the cluster, they will run the audit validation script and then validate what are all the service accounts, what are all the permission it has. If it has excessive permission, it will be failing in your audits. So then that time you'll have to fix all of these. So it's better to start from there. Let's start from day 1 to have minimal permission. So just understand and then make it. But sometimes Istio Cilium requires excessive permission. So that will be your exception scenarios. Like you should not use cluster role and role binding for your application teams. Right. So they should really have access to that namespace level resources. So accordingly, you have to design your infrastructure and the resources that you are deploying on top of it.
Do we have concept of groups here, like group permissions and something like that?
Yes. So we, instead of user, you can just pass the group and group name. Okay.
Okay.
But in the real time, to make it work, you'll have to have IAM or Azure to make that as a real user, right? And then authenticate to the cluster using that group and then that user and then check the access. But since we are using the lab in the kind cluster, we cannot make use of the underlying Azure AD. So we are just mimicking it with the sample user and sample group. Okay.
My question is, let's say from AWS I log in, I have one group and all of that. So does EKS recognize, I mean, from AWS means I'll use EKS, but if I want to use externally Kubernetes, will I be able to parse that same group here, or should I have to create a similar group and map that same sort of permissions?
So basically, when you create an EKS, so you'll have to have an authentication mechanism to the cluster, right? So how it will be done? Using you will integrate IAM, right? So that means you can make use of the AD groups, like groups and users that are part of your IAM, right?
Correct.
So just you will integrate it with the mechanism, the IAM or AD mechanism to authenticate to users. So once you integrate it, then you will have all the groups visible here as well. So you can make use of that group and then use it in your role and role binding. So basically you start with the cloud RBAC, and then once the cloud RBAC is enabled, then comes your Kubernetes RBAC. So specifically you can deny inside your Kubernetes cluster. So if you don't want to make this much complicated, like without creating cluster role and cluster role binding, so for a small and for a POC kind of setup, what we do, we just make everyone as cluster admin. Don't even create any role and role binding and make it this much complicated. So just assign the cluster admin to group. So whoever part of the group, they will have full access to the Kubernetes cluster. So ensure that only cluster admins are added to that group. So with that group, they will have full access to the cluster. But when application teams, like testers or developers, they want access to the cluster, then comes this part, like role binding, you'll have to assign so that they can only access to their applications. Like only access to their namespace. Okay?
Okay.
So two different types of RBACs. One is cloud RBAC, another one is Kubernetes RBAC. So mainly we are focusing on Kubernetes RBAC. So to make the groups available for your Kubernetes RBAC, the prerequisite is it has to be integrated with your cloud RBAC, external RBAC, whichever is there.
Oh, got it. Okay. Thank you.
Yes, where were we, Priyanshu? So you validated all the access ticket stuff, right?
Yeah.
I think, yeah.
Yeah, do I need to run 71 command? Like
it's okay, though. Skip it, it's fine. So it's
yeah, can you just explain the 76 number? Like we are just what is this?
Go back to the cluster role file.
Yeah.
Cluster role. Yeah. Come down. I've just added, I think you raised a query yesterday, right? How to add service account. Yeah, wait. 32, line number 32. So now I'm creating a new namespace, right? Called demo namespace. And then I'm inside that namespace, I'm creating a service account. Line number 38. I'm creating a service account. Then come down, line number 44. So this is your role. So now I have permission for pods and deployments. So all these permissions I have assigned, like these are the roles. So role is nothing but the job that's available in your company. Okay. So its job is available, but how to do it? You have to assign it to an employee, right? So job is always there, but to make it done, you have to assign it to an employee. So that is what the role binding. So without role binding, so nothing can be done. So this role can be there, like without even creating a role binding, roles will be there. Like by default, you will have different roles. But to make it accessible to a user or service account, you will have to assign it. That's called your role binding. So always this will be in combination. Okay. So now if you see here, I have created a role and role binding. So which role I have added? Line number 66. 66. So role reference, I have given role name reference. So which role I'm going to assign. To whom? Line number 61. So that will be under your subject. So for service account in that namespace. Okay. So only this service account will have access to that deployment. Okay. For example, if you use this service account in your deployment, then this will have access to get, list, watch, create pods and deployments only, not for listing your persistent volume, or not for your storages, not for your networkings. Okay. So I think, yeah, this is how we give permission for service account. So this is going to be similar like I showed you for Cilium, right? So for Cilium, it's going to be cluster role because it has to look into all the files and then create all the resources, like cluster level resources. That's why it has cluster role and role binding. So specifically for application team, this role and role binding should be enough. And if it's for a user, the kind will be user, group, it will be group, and service account, kind will be service account. But service account, you must specify namespace. For service account, you have to specify the namespace. If you don't specify the namespace, you will get an error. Because service account is a namespace scoped resource. So that's a must. Okay. So that we are done with the role-based access control. So now let's move on to the Helm chart. Okay, so open the file without Helm chart. Yeah, so here we are creating a lot of files, right? So demo, config map, and then scroll down. So secret, service account, all these we are creating in deployment. So these are all the files that we are creating. Yeah, so these are the samples that we were talking, okay, in the morning, that without Helm chart, these are the configuration files. You don't need to apply it. So just for understanding purpose, I've created this file. So that's fine. So now we are going to create a Helm chart. So before creating the Helm chart, can you do one thing? Can you create a new folder under this? Because I have created the Helm chart here. I don't want you to reuse it. So you can start it from scratch. So now run the Helm create demo app. So you are creating a Helm chart now. So go inside the test and see what's there. So it did create a folder, right? So this is the structure that we were talking about. Okay. So by default, it created all these resources inside the templates, whatever required for your deployment. So it had created few resources. Okay, so these are the files. So by default, it just created all these files. Just open this helpers.tpl. So that's one important concept. So for example, across your organization, you have some specific set of labels that are required. So you don't have to reuse it. So just define it here, like your company name, or your, if this application belongs to HR, so they will have their application IDs. So such type of resources, you can map it here, like such type of labels or whatever required. So you don't have to reuse it across your different Helm chart. For example, I have HR app. So HR app will have application ID or cost center for that application. So all these you can define it here. And then if you can just mimic it and then create one more app called finance app, and then still use the same cost and still use the cost center variables, just to pass a different value to it. So with that, you don't have to create a different types of Helm chart for each and every team, just override the values. So this is nothing but the TPL file is a template that you can reuse it across. So the structure, it will look like this, like two open bracket hyphen define means defining the files. Okay, defining which in the demo.apps, what's the name of the file. Okay, if you specify the name, it will take it. If not, the default value, line number 5, default chart name values override. In the chart, you have specified a name, right? Demo app. That will be taken if you don't specify any name. Okay, so if you want to specify a name, it will take it from the values. Like when you do the Helm install, you will give the name. That value will be taken. If not, it will take the demo.apps, whatever there in the chart.yaml. So like that, you can define few set of predefined thing in this template TPL file. So this is mostly used widely across organization. But for a startups, like they don't start with this, but just understand what's the use of it. So if we have to reuse or predefine few set of variables, you can make use of this TPL file. Okay. So now go to the deployment.yaml.
What is trunk 63? Is it
63 means, so in Kubernetes, can you create a deployment more than 63 character? No.
Okay, got it. It's a character.
That's blocked. So each and every CRD will it has ability to create a resource name up to 63 characters only. So that is called function. Can you go back to the TPL again?
Yeah.
So that's called the function that we were talking about. So trim suffix is also the function. So all these are functions. If you want, you can make use of it. If not, what will happen? It will allow 64 characters, and then what will happen? You will see errors. Deployment will not succeed. So in order to avoid it, so whatever is there up to 63, then it will just remove the rest of the characters and succeed. For example, I've given a long length of name. Up to 63, it will take 64, 65, everything will be discarded. Okay. To ensure that failures, such type of issues are addressed here. Okay, but we don't need to discuss all the functions now, but just understand what's the use of functions. And then sometimes some obligation needs everything in uppercase. For example, environmental name, database name need to be in uppercase. Then you can use upper function and then change it to uppercase. Okay, so you can make use of functions like that.
So these things can't be mentioned in the chart.yaml or config map secrets.
Basically, you can just skip this template TPL file itself. So it's not always mandatory to specify it. So if you don't specify, what will happen? It will take whatever values you are providing. For example, if you do the Helm install, it will generate a random name for your deployment, for your application. Okay.
Okay. Basically for the default things.
For no. For example, if you do, we are going to do that. Just wait for a minute. Okay. So maybe you can raise it at last if you still have any queries. Are we clear with TPL when we will use this?
Yeah.
Okay, good then. Just to go back to the deployment.yaml. So this is how your sample deployment will look like. Okay. Come down. So all the values, you can take it from values.yaml. Values, liveliness, probe, yeah, indentations, everything will be mentioned. Why is the use of indent? So some requires like there should be an indent, right? So YAML is indent sensitive. If you do the incorrect indent, it is not going to work. So it has to be at the right indentation. To ensure that values are passed in the right indentation, this n indent function is used. So you are seeing that n indent, right, everywhere. So at 12 means under, for example, yeah. So here at 12 means inside the container, it is going to be a 12 indents. Indents will be there. Okay. Just come to line number 64. Right. So if you see here, just 8 indents because it's few characters before. Got it, right? But we are not going to create all these every day. So just understand what is the use of it. I will tell you how you can use this. So basically, we don't create it from the scratch. But once in a while, you might create. For that, you just understand these concepts. That's enough. Just go down. But do you think that this is our deployment file? No, right? So we need multiple files and we don't need a few set of files, right? And then this is the deployment file. Go to the next file, HPA. So this is the HPA. This is fine. We also need HPA. Go to the next file, HTTP route. So did we cover this? No, right? We did not cover this yet. So we don't need it, right?
Okay. We can also pass the conditions.
Yes. If it is enabled, then only this file will be deployed. Otherwise, this complete file will be skipped. So how to disable it? Inside the value, we are going to make enabled equal to false. Then it will be skipped. Okay, we can skip few files. So yeah. Ingress, yes. So this also we didn't cover. We can skip it. Like we can disable this file. And this is the service. This is the service account. So it's bare minimal file it created, right? It did not create all the files which we were looking for. Okay. And just, yeah, open that chart.yaml. So in the TPL, what we mentioned, if you don't mention any Helm release name, it will take this demo apps as the release name. Okay. Line number 2. So if you don't mention any release name, then a demo apps will be your release name. If not, you can mention your own name, like app team 1 or something like that. Then it will be your Helm release name. Okay. And the description and the version. So all these are required to do the Helm upgrades and Helm rollbacks. So it's based on this. So you have to, so if you change anything inside the deployment, add a few fields there. So then what you have to do, you have to create another version. So upgrade one version and then do a release. Okay. So now, yeah, click on this. So this is the important file. So this structure you need to understand. So replica count is going to be mapped in deployment. Okay. And then image, if you don't specify anything, these are your default values. Okay. So image section for image details, image pool secret. If it's for a private repository, service account, if it has to create a service account, then it will be your service account session, come down. So if you have to add any labels or annotation, so that's the next set of fields. Yeah. So that's for the service account. 36 and 39 are for pod annotation and pod labels. Yeah. So if you want specific labels for your application, you can pass in here. Okay. So security we have not covered, but yeah, these are for the security related fields. And service, which type of service you need? Is it a cluster IP? Is it a load balancer, or is it a node port? You can specify it in the under the line number 55. And which port? 57. So it's specifically for service. Okay. Come down. So line number 60. So if you enable, if enable is false, then ingress will not be created. So once it is false, all the rest of the parameters, even if you specify it, it is not going to take unless you enable it. Okay. So these will be ignored if it is false. Okay. Similarly, yeah. So these are specifically for ingress resource, for your application URLs that is going to be exposed outside. So we will check it in the next class. That's fine. Just ignore it. Ignore this. So a HTTP route also you can enable or disable, and then you can configure all the required parameters for HTTP route. Ignore for now. So resources, request and limit. If you don't specify anything, it will take the default. Yeah. Liveliness probe, readiness probe. Yeah, this is, if you want, you can change it as well. And auto scaling. So this is disabled. If you want to enable it, make it true and then change the replicas as per your needs. Okay. So that's going to be your volume. So you have to mention whether it is from a persistent volume claim. So here you have not seen any persistent volume claim here, right? So then this Helm chart is not supporting persistent volume at all. Okay. There is no persistence volume plane created under templates. So what you have to do, you have to create a persistence volume under templates and then pass the values from the values.yaml. Then only it will be deployed. Okay. So like that, you will have to add the configuration. Now what you do, go back to week 4. So I have created demo app. I have created a folder called demo app. Open that, templates, click on templates. Yeah. So I have mapped all the files that we discussed. So cluster role binding. So I'm not giving all the fields from values.yaml. So few fields only I'm taking it. So rest of the fields I can hard code it also. Okay. So this is how it is going to be. Okay. Deployment, HPA, services. So whatever files we discussed so far, I have covered it. So this is how it is going to be.
TPL is not necessary, right?
Not necessary. Yes. That's why I have ignored it. If I want it, I can include it and then set few standards. So if not, it is going to fail if it exceeds 63, but that's fine. We know what we are doing, right? We are not going to create a vague names, and also we are going to name the release. So that's fine. We don't need to have a TPL at the moment. And also TPL file is managed at the enterprise scale level. So you know the use of it, right? So you can make use of it whenever you require.
And one more thing, is it a Helm version?
Yes, Helm chart version. So one is your Helm chart version, one is your app version. So inside the, so for example, I'm creating a Helm chart version today 1, okay, 0.1.0. That Helm chart version is having an app like a deployment, which is having a version 1. Okay, so it's the deployment version. App version is your deployment version. The plain version is your Helm chart version. So tomorrow, if I change the version to 0.1.1, and I'm not going to change the app version, is you can just keep it as it is and then you roll it out. So it's one is for the deployment, your application version. So application in your deployment, what is that version that's pointing to? So that's your application version, and one is your chart version. So some of the Helm release vendors, they keep it same, some don't. Okay, don't get confused. So chart version is nothing but that's not your application version. Application version is mapped in app version. Okay. So you will understand it when you roll it out. What's the difference between app version and your Helm chart version?
So Lavanya, so if we are having some base template in one of the repos, and if we want to call this in our child repo, can we use the chart version as the base templates?
So for that, these files need to be pushed to Artifactory, right?
Yeah.
So if the, for example, if I have a Cilium, okay, that's there in the Artifactory already, you can just call the same version and then deploy it in your application by overriding few fields. That's possible. Yes.
Okay.
So just in the base, you are overriding few fields and deploying it. Okay, but chart version is mapped to a specific application version. You cannot change an application version there. Okay. So for example, if this chart is mapped to 1.0, you cannot deploy 1.1 with this chart. For that, you will have to upgrade to the next chart version, which it is supporting. So I'm not talking for this sample application. I'm just talking about, for example, Cilium or Istio. They will have a specific set of version defined for that chart version. So that is where this is important. Okay. Okay. So now go back and then deploy this Helm chart.
Okay.
So here are the values that I wanted to override. Okay. So Helm install demo release is my release name. And then where the files are there, it's there under /demo app. You're already inside. Yeah, that's enough. You can roll it out. Okay. Yeah. So do one thing, Helm template. Yeah. And give the chart name.
Okay.
Template. Yeah. It is template. Okay. Repo name is /. Yes. At the end, you can give /. Yeah.
Okay, got it.
So when you see any problem in deploying it, this is how you will debug. So what all files it rolled out. Okay. So how you will check it? So without template, you cannot visualize what value it has passed, right? But with template, you will get to know what value it has really passed from the values.yaml. If you do some misconfiguration in values.yaml, you will catch it here. Okay. For example, some fields it's not passed, values are not passed, then it will be empty. If that's the required, it is going to fail. So this is how you will debug it. Okay, so take all these files and then you can deploy it and check what's the problem, then fix it in your Helm chart.
And with the help of Helm, can we do linting of this file?
Yes, you can do that. So a lot of linting is just for formatting and then checking any syntax errors, right? That all the Helm related CLI commands, you can do that in the, for any charts, that's fine. Okay. So when it comes to, for example, if you do any release with Helm, it will add a label like 84, line number 88 is there, right? Sorry, 88. Yeah. So kubectl label in the readme.md.
Okay.
Yeah. So in the readme here, if you see, so we are not going to add a label definitely for all the Helm chart, right? So by default, if it's rolled out using Helm, this label will be added. Okay. So if you have deployed it, right? Just check the deployment now. Kubectl get or pods. Just check the pods. Demo app, right? Demo namespace. So it's there in the namespace demo. Kubectl get pods namespace demo.
Okay.
OYAML, -OYAML.
Label app demo.
Come down. Okay, so we have not defined the Helm label at all then. Okay. But when you deploy it from the Artifactory repository, it will add this label. I think that's why I have added this label, like to see. So you can just validate from the pods itself. It will have this label managed by Helm. So let's see it for the Cilium chart that's below. So just go ahead and install Cilium in the line number 93.
Okay.
Yes.
Actually, I'm confused in between label and the annotate.
That's fine. That's what we are going to see.
Okay.
I was expecting it to add managed by Helm. I think I did not do that. That's fine. Now let's see it from the Artifactory Cilium repository. Okay. Reports. Namespace cube system. Okay, just choose any pod and then do OYAML.
Namespace.
Namespace.
Okay.
Go up. Can you search as Helm? Grape Helm.
Okay, 1 second. No.
No worries then. I think you can just ignore this, but by just understand, maybe some of the charts are having managed by Helm labels and annotations. But
Yeah, there is another field you can prometheus.io/port like that. That is the annotations. Right?
no, that's not the one that we are looking for. Basically, it has to had managed by Helm, but that is coming from the Artifactory itself. It's not from us. So if it is managed, so if they add the managed by Helm, then it comes in. Okay, that's fine. So just ignore it for now. Ignore the label and annotation. We will see. I think Argo CD will have such labels. So we will check it when we deploy Argo CD. Okay. But just understand why labels and annotations are required. For example, if you have some pods, some of the pods are managed by Helm. If you add this label managed by Helm, then you will get to know it's coming from a Helm release. Okay. So for that purpose, it is very easy to identify. Though the same deployment can be done from Kubernetes manifest and also by Helm. So it will be easy for us to understand from where these pods are managed. So sometimes it comes from Helm, sometimes it comes from Flux CD as well. Flux CD or Argo CD. So such type of labels will be there. Okay. For few deployments. But for Cilium, it's not there. Maybe for rest of the deployments, we are going to use Helm chart for all our next sections. So we are going to install Ingress Istio using Helm chart. So we will check it on the label and annotation there. Okay. Just ignore for now.
Okay, ma'am. Actually, yesterday I just created this file. Okay, and I have mentioned that annotation. Okay, so when I just hit the command kubectl like rollout history. Okay, so it shows this message. Okay, so like how we got to know like what annotation should be passed, like from where we can get this.
So basically, this annotation you can pass in during the rollout, right? Rollout and rollbacks. So that time it's pretty useful. So that's the use case that I see for your rollback and rollout. So basically, you have to add the annotation using the annotate deployment, and then when you do any release, like update the image version or whatever, if you want to update, that time you'll have to pass in the annotation as well. So releasing 1.20, something like that, you have to add the annotation along with your rollout. Then only it will add. Otherwise, it will not.
Question is like for this specific notation, it is used for the rollbacks. Okay, so like, can you just give me the example, like what kind of notation is available, or what are the use cases? Like for this specific, this is used for the rollback. So can you just give the another example?
So basically, annotations, so labels are for identifying the applications. It's our identifier. But annotations are for enabling few features. For example, if you have to enable monitoring or something like that, then you will have to add an annotation to enable some features. So that time annotation is important. Okay, so just to enable few features, if that annotation is there, then it will scrape the metrics. So for such use cases, these annotations are helpful. So in your case, you are using it for rollbacks, right? But some feature releases or feature enablements, annotations are useful. So based on, because you can use the annotation label as well, right? But labels are specifically designed for selectors. Like you can select make it as a label selector and then choose it in your services and all, but you cannot use that as for annotations. So you cannot do an annotation selector. So your annotation is nothing but adding additional information to your deployment. For example, label has restrictions of these characters are not allowed, but annotation does not have specific details. You can add your description also there. So both are different.
Okay, got it.
And then for feature enablements, these annotations are widely used. Okay, so if you have such annotation, it will enable the features.
Okay.
But label for mainly for selectors, selecting your deployment and then exposing. So in the services and then in the ingress controllers, for all those things, labels are used. Okay, I think so check the line number 95 and the readme. Yeah. So what this is doing? So what's the difference between this? Why we need to have this set command?
Like it will remove the group proxy. Like if we create the cluster with the help of kind, so by default it creates the group proxy. Okay. So when we are installing the Selenium, so it will replace the Q proxy and install the Selenium, right?
It's like passing values over the env values was set.
Yes. So there are multiple ways to override the values. One is using values.yaml. In the values.yaml, you can override the values. But there are other ways as well. So you don't want to replace all the values. Only few set of values. If you want to replace, you can use hyphen set. Okay, I'm sharing my screen. Is it visible?
Yes.
So I have pulled the Selenium files. Okay. So when you do a pull, so this is the Selenium repository, and then this is your Selenium chart. Okay. How you will search which repository? So basically, you can search any repository. Helm, search. So in this chart, in this repository, so this is the repository, Helm, search, repo. In this repo, I'm just searching all the charts. So it has 3 different charts, Bitnami chart and Selenium chart and Tetragon chart. So basically, we are using the Selenium chart, right, for rolling out the Selenium. So this is your repository and this is your chart name. So now I'm checking, it will only give me the Selenium chart. Now I can pull that chart to see what are all files it has, right? So it will be pulled as TGZ. It's a tar file convention. So how to unzip it? You can use the tar unzip to unzip this file. And then if I unzip it, it will unzip everything. And then we can just check what and all files it has. Yeah. So if you see under this template, it has multiple different folders as well. So it has a lot of dependency charts. So it has Selenium agent has its own templates, and then Selenium envoy has its own templates. So this is one of the complex example. But yeah, I hope you all understand this. Like, so these are the dependent charts. It installs it. So based on the enable or disable the Q proxy replacement, it will deploy that specific dependent charts. Okay, so these are the files. So why I'm interested in it is this values.yaml. So in this values.yaml, I have something called as kube proxy. So Q proxy replacement, right? So I don't want to do a lot of changes. All that I have to do is I have to just replace this Q proxy, and then I want to make it to true to use the Selenium as my Q proxy. So if I make it to true, then rest of the values I don't want to edit. In such case, you can use Helm install set Q proxy equal to true. So this is going to what this is going to do is this is going to only change this file, and then rest of the values it will come from the default configurations. Okay. And then I'm also doing another configuration change like set API gateway enabled equal to true. So this is another set of change that I am going to do. So all you can do is you can enable the log or disable the log. But what is the complexity of using -- set and values.yaml? What is which is best you consider? Just can someone answer? So which will be good for a real production use case?
Values.yaml.
Values.
Yes, values.yaml is the live production example. But if you want to do some testing and all, you can just override using set command and then make use of it. Okay.
So it prioritizes the set values first, right? Even though we have given false here in the values.yaml, so it overrides for the current scenario. That's all.
So we are not actually giving this. So this is pulled from the centralized repository, right? So
Yeah.
we are not creating this YAML at all, right? So it's pulled from the central repository. So how we are installing it? We are enabling it or disabling it using set command. So from the centralized repository. Okay. So you can do this using this, or you can do -- values and then values.yaml. So you can use both of them. Okay. -f and then values.yaml. I don't have values.yaml in this folder, but yeah, so you can just give values.yaml. So in this folder, it will go and check for values.yaml, and then in if the values.yaml has this value, for example, if I make it to true, and a few other changes, like if I make the log system load, these are the values it is going to pick up. Okay. The monitor is equal to true, it is going to take all these values. For changing lot of values, you prefer values.yaml. Okay. Not necessarily you can change the values.yaml to custom values.yaml as well. So and then you can just pass in custom values.yaml. Okay. So not necessarily values.yaml. It can be any file you want. So just keep the values.yaml as a backup and then change it. And then you can deploy it. Okay. Yeah, Helm is an important tool because we use Helm widely in any production releases, be it application or be it specific tools to install, like Prometheus, Grafana, Istio, Cilium. All these can be installed using CLIs or also using Helm. But Helm is the widely used package manager in Kubernetes. You must know Helm if you are working on Kubernetes in and out.
Lavanya, like we do for container images, we push it to ACR and consume it in real time. Can we like create a Helm chart like demo app and push it to centralized repository and pull them when needed?
Yes, very good question. So basically, you can create a centralized Helm chart. Okay, like you create a Helm chart, demo app, a Helm chart we just created, right? Yeah. So you can push it to any OCI repository, container registries. Okay? And then from there you can pull it and then upgrade, like override the values and roll out in your cluster. That's possible. So you have to you have to pull it from the RT Factory hub, or you can do it from your own repositories, like your own container registries as well. But container registry has to support this Helm chart hostings. Okay, I think ACR supports it, but not all the registries are supporting. So GitHub also supports, GHCR supports the OCI image Artifactory as well. So if it supports, you can pull it from there as well.
So you should configure when we do Helm pull, it should come from our OCI.
Right.
Okay.
That's right. Okay. So here it is not going to be your Helm pull. So basically you'll have to have permission to pull that image itself. So it is going to be an image, right?
Yeah.
So you have to have permission to pull the image. Once you pulled that image, Then you will have to unzip it and then roll that as a Helm chart.
Okay.
Yeah. I think we are done for the day. I have given an assignment for the yesterday session for storage class and RBAC. Maybe I'll try to add one for Helm chart. So yeah, with that we will close for the day. Any questions? Good then. Thank you for the active engagement. I look forward for such an engagement so that I might cover few areas, but not all, because each and every tool has its own timeline to cover. Like one week for Cilium itself will take. So we cannot cover all the features that are available in Cilium. So what is best we can cover, we will cover. So if there are any questions, then we will cover them. But yeah, I'm going to send the next week session as well. So maybe I'll give it a day or 2 day prior so that you can come up with some questions. Then we can discuss in deep. Okay. So next class is going to be on Istio and Nginx ingress controller. Okay. Thank you.
Lavanya, one last doubt.
Hmm.
Like, what is the difference between ingress and metal LB?
So Meta LB is for load balancing solutions, right? Basically for public IP creations. So that's for provisioning or allowing the load balancer creation. But for ingress, it is specifically for exposing your application outside of your applications using the load balancer IP that you provisioned using Meta LB.
Okay.
Okay. But next week we are going to cover the Meta LB for kind cluster. So that's how we are going to provision the load balancer in our kind cluster, and then we are going to use the ingress, and then yeah, possibly we'll deep dive into the Istio as well as service mesh. Okay, feel free to join next session. So I would like to break it into 2 sessions, Friday and Saturday. So same class, same timing. So please feel free to join. But if you want to change the timing, just post in the WhatsApp group, then we'll go for a voting and then we'll change the timing as well.
So what about Terraform, Lavanya? Actually, while giving the demo, there was like 1 week of Terraform and 1 week of Kubernetes, right? So what's the plan?
Actually, we are going to cover the Terraform. Since we are going in the flow, I don't want to break it. So that's why I have pushed the Terraform to the end of the session. But if you understand all these concepts, it's going to be easy to understand the Terraform. It's not going to take so much of time. So that's why I'm pushing the Terraform to end of the course. So because we are in full flow with Kubernetes, I don't want to break it. But if you feel like we want 1 day of Terraform and 1 day of Kubernetes, that is also fine. So I thought
No.
going in the flow, like you all are giving good examples of Kubernetes manifest. I feel like you are getting the concept very good. Like yeah, so all the fields that you're recollecting it, so which is going good. So that's why I'm continuing this Kubernetes, and then let's finish it off with all the tools. Then we'll deep dive into Terraform.
Okay. Yeah.
Okay.
Thank you.
Okay.
And one more request, like, can you give more of the assignments which will be helpful in the real time, like that, so that we'll be getting an exposure in doing debugging, something like that.
Okay. So what I will do, I will give an assignment on the topics which I was not covering. Okay.
Yeah.
That you can explore it yourself. I'm not going to give the same topic which I covered today. Maybe wherever I missed it or some of them that you can go through yourself, I will cover few assignments. So I'll try to give at least 2 assignments for each of the topic that's covered so that you can explore yourself and come up with some questions.
Yeah. Thank you so much.
And also one more thing, like when we cover one topic, so can you please share the interview questions, like what kind of tricky questions they can ask?
I think the questions that I'm raising it every day, just make a note of it. Similar questions only you will get.
Okay.
Okay. So we are discussing questions prior to the
Yeah.
right? So mostly it will be it. And also I'm giving the production use cases. So those are to make you understand how a production environment will look like. So those are also important. So maybe what we can do a mock interview if time permits. After 9 sessions, we'll allocate one single mock interview session, and then we can raise questions. Okay.
Sure, that's great.
Yeah, one session will allocate 1 hour, 1.5 hours, 1 day session will allocate only for mock interviews, so that I will cover all the topics which has been covered for the 10 weeks. But I'm not giving an explanation in that call to cover most use of it. So you'll have to go through yourself if you don't find an answer. Okay.
Yeah.
Then it is going to be like it will be very short, right? So yeah.
Okay.
Okay, all good then. Yeah, if you have any question, just pass it in the WhatsApp group as well. We can discuss it more. And then I will plan to add more assignments and see how it goes. Okay.
Thank you so much.
Thank you. Thank you for the feedback, Kolika. It's taken. Thank you, guys. Bye for today. See you in the next class on Friday. Bye.
Bye.